Buon pomeriggio.
Good afternoon to you all. My name is Maua, one of Bergamo Scienze volunteers. Before starting, we would like to kindly ask you to remember that connecting to bergamoscienza.it site and clicking on live, you can post on Facebook and Twitter the live event, send questions to speakers, or invite one's friends and followers to follow the conference online. Questions from the web are received by us, and we will be selecting them during the question and answer session. For simultaneous translation, you should scan the QR code on the doors of this room or my back, and the QR code will be addressing you to the Converso web app, where you can select the interpretation language from the scroll down menu. To listen to the translation, you need a pair of earphones, so you kindly invite you to use your own. Those who haven't got one pair can ask our volunteers. Please mute your devices and attend our initiatives. Thank you very much for listening and enjoy the evening. Good evening. Good evening to you all and welcome. Tonight we'll be speaking about robotics, industry and innovation. And we are honored and pleased to have here with us two worldwide experts in this field. They both were awarded the Engelberg Robotics Award for 2022. Professor Bruno Siciliano from the University of Naples and Bertil Thorvaldsson from ABB. I'd like to introduce our two speakers, and then they'll have a conversation and we'll speak about robotics and technological innovation with them, instead of making a list of all their career and biographical data. I'll be introducing them by using video clips. I will now ask the control room to show the first video.
I was born in Napoli in 1959, which was the year the first industrial robot was made. I did my studies and my whole academic career at University of Napoli Federico II, and I always wanted to reach my goals here.
Napoli is a city which naturally trains to complexity and inspires the people living in the city to develop a spirit of creativity.
Our Prisma Lab has been active in robotics since the mid-80s. We have grown up according to a bottom-up approach, from industrial robots to the level of interaction with the structural environment, as in field and service robotics applications. Our dream and our goal at the same time has been to make robots useful and acceptable to humans. Our research work is in three main areas. We have developed bimanual robots and anthropomorphic hands for dexterous manipulation. Thanks to my ERC Advanced grant, we have expanded the team with complementary skills to work on non-prehensile dynamic manipulation and manipulation of deformable objects. We have designed sensorized grippers for handling tasks of robots in supermarkets and retail stores. Both industrial plants and civil infrastructures constitute hostile environments requiring mobile, marine and aerial robotic technologies. We have developed multicopter drones for non-destructive testing of bridges and viaducts and for aerial cooperative manipulation of payloads. We have designed a hybrid drone which can fly, roll along and inspect pipes, and an aquatic drone for eco-sustainable reuse of offshore platforms. What is the benefit of these technologies? Reduction of costs and risks. The operator can safely guide a remote robot, which then can execute tasks in a semi-autonomous way. In the field of surgical robotics, we have introduced techniques to provide a surgeon with enhanced multisensory perception, including tactile feedback, which is still missing in today's commercial systems. We have designed mini-hands and tools for laparoscopy, prostate biopsy, and suturing. At the frontier of theranostics, we are developing a new version robot with a dual-arm micromanipulator for one-stop diagnosis and treatment of precancer cells during a colonoscopy. We have introduced the instrument of small-scale experiments aimed at turning prototypes into successful products.
While strengthening the cooperation between academia and industry in the various experiments, there will be an added value brought by the project.
Another instrument we have introduced is that of the challenges through the exploitation of synergies across all the stakeholders to speed up the process of bringing innovative technologies from research labs to industrial end users. We are also active as Digital Innovation Hub in the European robotics scene. Our research has also had a great impact on education. In the latest few years, at University of Napoli Federico II, we have been observing a constant increase of numbers of master's students graduating in robotics. Thousands of students at universities around the world study robotics from our textbook. The textbook contents are also available in terms of 2 MOOC courses for web learning education. Where is robotics going? Reaching for the human frontier, robotics is vigorously engaged into the challenges of new emerging domains. New communities of users and developers with growing connections to robotics are coming together, and thus our strategic goal should be one of outreach and cooperation with these communities. The inherent interdisciplinary nature of robotics is well captured by the Spring Handbook of Robotics. The handbook received the prestigious Prose Award in the category of engineering and technology, and remarkably, it was also the winner for excellence in physical sciences and mathematics, a true consecration of robotics as a science beyond the boundaries of engineering and technology.
Thank you very much. This video is filled with the very fascinating ideas and things. We'll now introduce our other guest, Professor Bertil Thorvaldsson. Please show the second video.
Already when I was born, my grandmother expected me to become an engineer. There was this famous engineering school named Chalmers University of Technology in the city where we lived. And she had high hopes that I would attend it. And it so happened that when it was time for college, Intel released the first microprocessor, and I was blown away with it and wanted to learn everything about computers. So my grandma's vision became reality. I started out in the robot industry in 1976 when I joined a small team at ASEA in Sweden, now ABB, that developed the world's first all-electric microprocessor controlled robot, the IRB6. Although we had no PCs, no internet, and no mobile phones, we were able to create a robot that was not all that unlike the ones we make today. After a few years as a developer, I left ABB to work with system integrators and end users in Germany, where I got a customer perspective on robotics. In 1985, I was recruited back to ABB to start an R&D department in Milwaukee, USA. There I had a chance to build a new team from scratch, something I really enjoyed and have been fortunate to be able to do several times again. We often hear that technology advances extremely fast, but I beg to differ. The things we were working on in the 1980s that we today would call IoT, digital twin, and AI are yet still just on the verge to become pervasive. After more than a decade in the US, I moved back to my native Sweden to start a new company named Digital Plant Technologies. The business idea was to develop tools to create what we then called digital replicas of real manufacturing systems. But we were out too early. It was too difficult to build digital twins of all the equipment in a factory. Often we didn't even have 3D models. So the company was acquired by ABB, and the scope was limited to ABB robot systems. We already had digital twins of these as a result of the work done in Milwaukee. We named the product RoboStudio, a trademark that has since earned respect among customers as well as competitors. The secret to success of RoboStudio is that it runs the same software that is running on the real robot controller. So what you see in RoboStudio is exactly what you get in the factory. That makes it possible to do virtual commissioning, designing, testing, and verifying a new manufacturing system in the virtual world, so that the startup in the plant goes fast and you can quickly ramp up production to full capacity. Already when we first started to develop RoboStudio, we intended it to run in virtual reality. The technology was available, but was too expensive to be commercially viable. So RoboStudio was confined to flat displays for a long time until it could finally be released in 2016, when inexpensive consumer devices became available. In RoboStudio, we were early adopters of VR. A particularly useful feature has been VR meetings. That has made it possible for users in several locations, including from home, to meet as avatars inside RoboStudio to collaborate on robot solutions. An even more promising technology is augmented reality. Being able to visualize robot paths, work objects, and safety zones in the factory will make it possible to use RoboStudio with real robots in the same way that it is used with virtual robots. And devices such as teach pendants that today are physical can be replaced with virtual ones. Just to mention a few of all the new possibilities that the metaverse will enable. I am proud of what we have accomplished this far, and I am really looking forward to the journey ahead.
Thank you. This too was a video that allowed us to cover the history of the last 40 years in technological development. So I would start from here. Robotics is extremely fascinating topic. Robots are very alluring. They attract our attention. When I say robot, I think of Asimov's stories of the 80s, the laws of robotics. So I'd like to ask, where did you get your inspiration for this passion? Where did you get your interest in robotics? Shall I start? Yes. Good evening. And watching Bergamo Scienze jingle video clip and the fact that Bergamo and Brescia next year will be the capitals of culture, I like to build this bridge because I come from Naples and it is Procida this year, which is the capital of culture. So this event, Fall 22, acts as a bridge in the relay from Procida to Bergamo and Brescia for the capital city of culture. Answering Enrico's question, and this is what I was telling some students before, is that in my case, I was positively influenced by my teenagers' readings of Isaac Asimov. At the time, robotics did not exist. Isaac Asimov was one of the most important sci-fi writers and still is. At the time, we spoke about cybernetics rather than robotics. there was no AI yet in our society, in our world, and robotics still had to be developed. In Bertil's video clip, you saw 4 decades of technological evolution, during which Bertil contributed to robotics evolution and development in the industrial world. I was lucky enough as to be born in 1959, which is the year when the first industrial robot was developed, based on an entrepreneurial idea by Joseph Engelberger. We shared this award, Bertil for the industrial part and I for the academic part, the education prize of Engelberger Robotics. So when I was 16, I'm thinking of the young students I met before, I would have never imagined that my full professional career could be lived through what was still a dream. It was still sci-fi, something in the far future. And then my dream came true. I got a degree in electronic engineering, and we'll come back to this aspect of what is the educational career that you can have to go and work in robotics. And so all my dreams came true, because when I started dealing with robots, robots were used in segmented areas. They were far from human beings, given that they were inherently dangerous for human beings. This is the first law of Asimov's robotics, and this object is a cobot, and it can be used intuitively as if it were a plug-and-play device. Millennials nowadays buy new smartphones, but never read the manuals, instruction manuals. They just use them, and so the evolution of these devices went through the 4 decades of evolution that Bertil highlighted in his video, and they witnessed a success, great advances. And as a European, I'm very proud of it, because even though the first robot was produced in the United States, it is from Europe and Italy, together with Sweden and Germany, that the most innovative ideas came in this field, at least. Fine. Thank you. Bertil?
So when I graduated from college, then the microprocessor just came out. And I knew I wanted to work with that. I just didn't know in what field. Until I found robotics, which at that time barely existed. And I thought it was so much interesting to work with computers that made things move rather than things that perhaps printed out a piece of paper. And also robotics included so many technologies, data communication, control theory, eventually vision, all kinds of things that I had studied in college. So it was easy for me to pick robotics. And early on, I was really interested in designing the computers. But over time, I got more interested in the applications. And that led me into all kinds of things.
Adesso
Having a look at these beautiful pictures, we inevitably become very passionate with robotics as well. But given that you have a clear view of what is the evolution in this field, my question is, aren't we running some risks? So besides being fascinated by these technologies, could something go wrong over the next years? So is there something dangerous in robotics? The floor is to you, Bertil, first. Bertil,
I'll start. So I'm not really worried about any dangers of robotics. I see robots as tools that help humans become more productive. And I think that rather than getting into a world where more and more things get automated, I think the opposite is going to happen. After Industry 4.0 that we are seeing now, where technology is really taking over and it's not so clear perhaps what the human's role is, we're going to move into something where the human is at the center, and the automation is just tools to help the humans. So I think the factories that we see today, where our phones are manufactured, for example, where humans are treated as consumables, they are standing in line outside of the factories, and if they are not treated well, no worries, you can always throw in a new person. And I think that is about to die. We're just not going to see that anymore. And there is an initiative called Industry 5.0 that perhaps not so many people have heard about, and it's very much about that, putting the human in the center, making things sustainable, changing the values and sort of the owners, and shifting the focus from profitability and growth to sort of quality of life. So I'm quite, I'm quite unconcerned about robotics in the future.
I'll try and elaborate what Bertil said very brilliantly. And it comes to my mind when I just got my degree and started my PhD. Then I visited a car manufacturing plant, a Fiat car manufacturing plant, what now has FCA as a brand. This manufacturing plant is still there, close to Naples, and I saw the first industrial robots. They were being used to assemble the various parts of the car. And I was positively struck by the reliability, the accuracy of these machines. But at the same time, I noticed that on the shop floor, there were still some workers, and it was very unpleasant to work there because there was plenty of noise and smell, a sort of visual pollution, because there were, again, noise, vapors, etc. I went back to the same manufacturing plant some years ago with a delegation invited by my rector. And they keep manufacturing cars because the assembly line of Panda is to be found in this factory. But the feeling I had was to visit a pharmaceutical company where food was manufactured, drugs were manufactured, everything was white, clean, and the workers were coat wearing technicians, no segmentation between human beings and machines. Why so? Why this change? Because the danger that was mentioned, that once was inherent in the previous robots, robot arms, which were stupid, dumb. They could not interact in a clever manner with their surroundings, thanks to the introduction and the use of sensors, IT, automation and controls. They were able to interact in full safety. I'm very passionate of cinema, besides football and food, whatever. But there is a beautiful movie that I always show my students when I held my lessons that goes back to 92 years ago, Modern Times by Charlie Chaplin, where you can feel the aberration of automation. And this is felt by Charlie Chaplin. Charlot is so alienated fascinated and he can never get distracted. Why am I showing this movie, Modern Times? Because the space-time sequences that bring about alienation of human workers that brought to the introduction of robots had completely disappeared, because it was the technicians controlling the space-time sequence along the assembly line some years ago when I went to see the FCA manufacturing plant. It was as if they were working on a work of art. So why am I saying so? And I fully agree with what Bertil said. Thanks to new technologies, thanks to robotics, robotics is a science, a discipline that is in the end controlled by men and the service of men. Industrially speaking, it can provide the tools that can improve, enhance product quality, because this is what we are interested in, but they also improve quality of work. And this is very important. And this is not the only place where we can use robotics, because I was discussing this with some students before. Let's think of healthcare. Currently, robots are being used both in surgeries. I mean, for surgical purposes, there is a robot system that was named after Leonardo da Vinci. Da Vinci is a robot. Once again, it is the Italians that marked the history of mankind. So in the case of robotic surgery, there is a system whereby the surgeon operates under circumstances which are ergonomically more relaxed, and surgeons can follow the operation, whether it is an hysterectomy or a prostatectomy or a general surgery operation, in a more accurate manner. And also, these are minimally invasive operations, and this allows patients to recover much quicker. And this is but an example. Some of the students I was discussing with before used the word exoskeleton. What is an exoskeleton? A robot that you wear. And they students spoke about this. I'm very much convinced with one of the statements in the video. I believe that robots are already with us, amongst us, and for us. So this is a technology that is bound to become, in 20 or 10 years even, ubiquitous, pervasive. What do I mean by this? We won't even notice that there are robots in the environment where we live, whether it is a school, a hospital, a hotel, an airport, not just factories. There will be robots everywhere, and these robots will be working together with men and for men.
Thank you very much. That's encouraging and reassuring. The idea that the robot is just a technology and man remains at the very center of this technology. But I would like to change topic. As we said, that there were students here in the previous slot, and many of the people attending tonight are, in fact, students. I would like to ask you, since you have a long-standing experience in this field, would you suggest a student to devote himself or herself to robotics, and what kind of curriculum would you suggest? I would like to have Professor Siciliano answering first. All right, I'll be answering first then. I studied electronic engineering in 1977. I was 18, and I enrolled not just because I loved electronics, because I never disassembled any piece of equipment. In those days, there were, there were people who used radio frequencies to communicate. I didn't have this passion. I was very good at mathematics and physics. I liked studying, so mathematics, physics, and today we can add IT as well, were the prerequisites to then devote oneself to robotics. Anyway, I enrolled to electronic engineering because I believe that was the future. In those days, the other option was electrotechnical engineering. There was no IT engineering in those days. There were no telecommunication engineering. There was no biomedical engineering in those days. And clearly, there was no robotic engineering in those days. Robotic made at the end of the 70s was just at the very, very beginning as a discipline. So why did I decide to study engineering? Well, out of curiosity and because I was fascinated by technology and the future of technology. And here we come to the question that Enrico asked. Is it necessary to study science or scientific disciplines to then devote oneself to robotics? I would say so, but if you like mechatronics, if you like technology, as is the case of some of you, some of those who were playing with Robot Studio and virtual reality, well, then at that point it becomes almost natural to study engineering. However, robotics is beyond the border of engineering, of mechatronics, of AI, of technology. And why? Well, the definition of robotics that is most widely used in the international scientific community is that of an intelligent connection between perception and action. So a robotic system implies three main components. Perception, so senses, in other words, so can feel, can perceive what happens in the environment, then execution, so the physical part, and then intelligence, that is control. Why am I saying all this? Because if technology is meant to be of assistance, in the media we read robotics and AI, but robotics, and this is, in my opinion, what makes it so fascinating, robotics adds the physical dimension to artificial intelligence. You are all familiar with Siri, Alexa, and these are intelligent algorithms that make it possible to dialogue with the computer. There's this perception and there's intelligence, but there's no physical action. If you add the physical dimension, then here we get robotics, and robotics goes beyond the borders of engineering and technology. It may sound contradictory, but if you want to develop an intelligent, high-performing robot, you have to know physics, IT, mechanics, electronics, engineering, mechanics, and so on and so forth. But robotics will not, the progress of robotics cannot depend only on people like Bertil or myself. Why? Because the design, the development, and use of robots all involve something that is not strictly connected with technology. For instance, would you ever would you ever trust a babysitter robot? Would you ever trust your child to a babysitter robot? Or would you ever entrust your grandmother or grandfather to a robot rather than a caregiver? But we have read, and we still read, cases of children abused or elderly people who are abused by their caregivers. So you may now understand what I mean. In order to study robotics and to develop robotics, we need the technology that has been developed over the years. But robotics pertains to other realms like ethology, the philosophy of science, and even the legal implications of robotics and the economic implications of robotics. So robotics is everything, is something that run across different disciplines. So we will definitely be needing technology passionate or technology lovers. But to develop robotics, we will certainly need something that does not belong necessarily to engineering. That was very interesting. What about you, Bertil? What would you suggest students?
So I think that it's definitely a good idea to get into to robotics now if you're graduating from school, for the reason that I think the market is going to grow tremendously. If we look at where automation has been applied this far, it's primarily at large corporations and some mid-sized corporations, but there are many small companies that are not using automation at all today. And I think in a very near future they will. And the reason is that we are developing different robots now that's going to fit that segment much better, like the robot that we see here. It's not so big and sort of scary as the robots that you see used in automotive. We have much smarter safety solutions that does not require us to put a fence around the robot. And in general, we have made it easier to program it. We have, we call these collaborative robots for a reason. It's because they are intended to work nicely with humans. And I think that the channels to market for these robots is going to be different. For the robot systems that are being implemented right now are typically being implemented by experts at system integrators. For these small robots to small companies, that's not going to be a feasible way. So I think that companies will order robots directly from the web, and they will apply them themselves to the applications where they want to. And I think that opens up new possibilities for working with robots, perhaps as a consultant or as a new type of system integrator, maybe as some kind of a computer store where you can actually touch and feel the things. So there's a bright future for robotics, I think. Also, what we will see is more local manufacturing. Recent events in the world has made it, questionable whether it's smart to source your components for your products on a global scale. It used to be that big companies had their office in India, their factory in China, and maybe their marketing in Europe or the US. I think that's not how it's going to be going forward. I think the way it's going to be is that everything that can be manufactured locally will be manufactured locally, and that will open up a lot of local job opportunities. So yes, robotics is a great field to go into.
Posso aggiungere una cosa?
Certo.
A febbraio scorso.
If I may add something, February last on LinkedIn, a statistical analysis appeared based on facts and figures, but also on the LinkedIn posts. So, as Bertil said, this is the right time to become robotic experts. Full-fledged robotic experts. Anyway, this statistical analysis showed, well, first of all, it analyzed the 25 jobs of the future, so the ones that will be most attractive and not just in the technology field, also in the banking industry and so on and so forth. Go to LinkedIn, have a look. You know what is number one? Robotic engineer. So that's the job of the future. Well, very good news then. Very good suggestion. But while you were speaking, I realized that talking about students, in Italy, we use the word students, but almost inevitably referring to masculine gender, which is not the case. So my question is, what about girls? What about girls? Can girls devote themselves to robotics? Can girls follow a curriculum in robotics, and will they be able to find a job? Bertil?
I think that robotics is not at all sort of gender specific. In fact, many of the best people that I have met in robotics are young females, and there may still be some kind of a misconception about manufacturing. When we talk about manufacturing, we may think that it's dirty, it's maybe heavy lifting, it's noisy, it's not very pleasant. When in reality, it is like working at an ad agency. You sit behind a computer, and you're working with things in 3D. Most of the work you do, you're going to do in the virtual world. In fact, everything that can be done in the virtual world makes sense to do there, because once you go out into the factory to implement things, it starts to cost money, and without actually producing anything. So no, there is absolutely nothing, I think, that makes robotics gender biased.
Sì, anche secondo me.
I agree, because in my research team I have different female students. Well, also I always call guys and girls, all my team members, even though they are 30 or 35. But I feel like being very privileged in my relationship with young students. 2 weeks ago, I started my annual yearly class on robotics. This is the 33rd year at University of Naples teaching robotics, and in my classroom I have half boys and half girls, also due to the fact that the class is offered both to students from robotics engineering and students of biomedical engineering, because in biomedics robotics is key. So I have 60 boys and 60 girls in my room, in my classroom, for my class of robotics. And I must say that both at a scientific and technological industrial level, there are very many women who distinguish themselves in this field. We were in Munich last June, Bertil and I. The Engelberger Award is divided into 3 categories. One is leadership, so people distinguish them in the industrial field. The second one is education, academics. And there is a third category, which is technology. And the colleague who was awarded was Melanie Weiss for Zebra Technology. She's much younger than we are, actually, and she's very talented, and she was awarded the Engelberg Robotics Prize. I mean, there are very many women colleagues. If I think of MIT, one of the most prestigious universities, technologically speaking, the director of the renowned computer science and AI lab is a dear colleague, Daniela Russo, who is the director of the laboratory and is a woman. So, going back to my example, the dirty, noisy factory and a brand new factory. This is a further justification of the fact that modern robotics, advanced robotics, can be of interest both for men and women. And indeed, I must say that another difference that I think of it, when Rico asked this question, I thought of it. In my visit 25 years later, I saw more women than men in the factory, in the FCA factory, because again, this factory was more welcoming, it was cozier, it was easier, more pleasant as a job, also for ladies, and not just male workers of the 80s. So your question brought me to consider this further feature of my visit to FCA plant. Given the comparison between modern times factories, dirty, noisy, repetitive, and modern factories that are clean and smart in their way of working, where jobs are more driven by intelligence than strength, yes, that would be a hindrance to being a woman. That's why I mentioned it, says Bruno Siciliano. So we spoke about robotics evolution, what happened over the past 4 decades. I'd like to look at the future, speak about the future. So I'd like to ask both of you, in what fields, in what industries do you believe the most interesting advances will be recorded in robotics? Because I listened to what Bertil said before about the usefulness and interaction between the virtual world and robotics. The fact that we use virtual models to use them in robotics and then in reality. What are the industries, the sectors where the greatest advances will be reported? Also, those which will be more fascinating. Well, I could say outside robotics. This is my short answer. Because over the past 60 years, the technologies that represent the kernel of robotics have already been developed. Now I'm having greater fun in attending non-robotic scientific communities than robotic ones. Why so? Because I'm convinced that any further advance progress in our field will not take place within the field of robotics, but in those cross-sections with other disciplines such as virtual reality, machine learning, prototyping, and this is still related to technology, but neurosciences would be another field, medicine, of course. But I would extend the field to sociology, philosophy of sciences, law. For instance, we mentioned the idea of safe robots. There is no case law or law about this. The European Parliament is still debating the fact whether a company installing robots must consider these robots as a worker, that it could hire. Should it pay taxes on these robots, robots' performance? Why am I saying so? Because it is outside robotics that we will be reporting the greatest progresses, advances. It is outside robotics that will realizing the dream of making robots more and more independent and intelligent. But given that I mentioned philosophy of sciences, etc., we cannot but consider also ethical aspects related with this discipline. And once again, It is in Italy that a new branch of robotics that was established, robot ethics. In Sanremo, a workshop was organized by some robotics experts in Italy, and I'd like to mention two people who are very active in this field. They deal a lot with the educational part of robotics. So I'm addressing now teachers present here, talking about robotics in their middle school or high school lessons. Fiorella Operto and Mr. Delugio. And Fiorella is committed in disseminating the concept of robotics in schools. During that symposium, we developed robot ethics. This is the ethics of designers, of implementers of robots, and also of users of robots. So this to tell you that this is an industry, a sector that is developing fast, and it is also an industry that requires contamination, cross-seeding with other industries, with other sectors outside the world of engineering and technology. Nowadays, when we say robotics, we no longer mean automation, engineering, technology, mechatronics. It goes far beyond that.
So I think that the biggest impact on the future is going to be technology again. And the technology that I see happening is the metaverse. Today we may not really know what that is. Does it have something to do with gaming? Does it have something to do with social media? And I think it's a similar situation to when the internet came. We didn't really know what that was. Was it an information repository? Was it the way to send files? What was it? And it turned out that it has impacted our lives in so many ways. The next thing that will impact our lives as much as the internet did is going to be the metaverse. And I think sort of a general definition of the metaverse is the world is going to consist of a mix of physical and virtual objects. And that applies to our lives in general, not particularly to robotics. But if you look at it in robotics, it's quite obvious what the benefits would be. So in the factory of the future, there will be physical things and there will be virtual things. So if we look at this robot here, for example, the arm may need to be physical because it's going to do things, and a virtual object can't do that. But then you take the device that's in front of it here, which is called a teach pendant. You can use it for programming and for operation of the robot. There's absolutely no reason why that should be made of plastic and metal. That can be made of pixels. And if it's made of pixels, it becomes much more flexible. You can scale it. It can be any size that you want to. You can hang it in thin air. You can hang it on the wall. You can locate it close to you and have it follow you as you move around. And it can change shape. There's really no reason why it would have to be sort of a rectangular shape anymore if it's made by pixels. And there are many things out in the factory that I think can be that. Maybe the first thing that will happen is various types of user interfaces. It doesn't really need to be a rectangle with buttons and lights or LCD screens. You can put the information where it's needed. So if you walk through the factory, information may appear as you walk along. A little bit depending on what you're interested in. If you're a service person, maybe when you look at the one of the motors of the robot, the temperature of the motor will just display there, and things like that. So I think that the metaverse is really going to change the factory, and that's really what I have chosen to spend the rest of my career on. Making happen.
let's see. So I can expect very, very interesting and amazing things to happen there. Scusate, mi aspetto quindi che succeda.
I definitely expected that very interesting and fascinating things will happen in this field. Now, speaking about the future, I'd like to ask the control room to show a video clip prepared by Professor Siciliano showing some of the very interesting and promising applications, and we'll see surprising things. I was amazed watching this video, how many things can be made. And then we'll ask our listeners online or our audience to ask their questions. So please, let's see the video.
veramente sorprendente.
Amazing, really amazing.
Bene, adesso
Well, time has come for you to ask questions. So if someone following the streaming of the event or someone in the audience wishes to ask questions, please do. But just to break the ice, I can ask a question myself first. We've seen many robots in the video that mimic what nature does. We've seen robots walking like dogs or like insects. There's one jumping like a kangaroo. So nature, through evolution, has generated living beings that have been able to adjust to the conditions existing on the Earth. So do you think we'll be seeing more of these robots going forward? You go first now.
So I think it's generally very exciting to try to have machines do what humans and animals can do. There's probably something really smart about it too. Maybe we'll hear more about that in a little bit. But I think that there's a reason why there's a reason why nature shaped things the way that it has. And it probably makes sense to try to learn something from that. Well, what do you say?
Sì, penso questo, nel senso che è chiaro che le applicazioni che avete visto,
well, the applications you've seen
prodotti commerciali,
will then become, one day they will become a product that will be marketed. This will happen in 10, 20, 30 years. In the industry, we mainly see robots that are assembled or mounted on an AGV, that is an automated guided vehicle. And why? Because a robot on the wheels is easier to manage than a robot with legs. In the movie you've seen, in the video clip you've seen robots with 4 legs or even 6 legs. Well, if you think of a robot with 2 legs, then of course these become a humanoid robots. I visited a startup that has grown, a startup that is near Bergamo, Carate Brianza. So I visited it a couple of weeks ago. Anyway, the CEO of this startup is an engineer, and he's really a visionary. They are developing a robot called Robi, and it's a humanoid robot, but not meant for these futuristic applications that we have seen in the video clip. So it's not the Atlas of robot dynamics that jumps or the one that you've seen probably last year that runs the parkour, and it has been viewed by millions of people. This robot will be used in the shop floor, so in a factory. So if the evolution of man shifted from the monkey to the human being, there must be a reason for it. So if you think of a robot that must operate in a non-well-structured environment, which is to say, not on the horizontal floor of the factory, for instance, but rather in an event of a disaster like a flooding or an earthquake. A colleague of mine, Robbie Murphy, that in those days was in the South Florida University, in 2001, when the terrorist attack was struck to the World Center, World Trade Center, she went to the site with her team and the robots that they had. So having a robot that can move on an uneven floor or an uneven surface can prove very useful. You've seen in the video clip the submarine robots, for instance, or the aerial robots. So the robotics will inevitably lead to hybrid machines like biomimetic robots. And then if you go to Wikipedia, you'll find that most of the pictures of robots come from Japan. So we all tend to think of a robot as an android that walks, that interacts, that can see, speak, and it is not accidental that robots are in Japan are inspired by cartoons like Mazinga or Goldrake. But there is also sociological and religious reason, because most of the majority of Japanese are Shinto. And so for a robot, for a machine to be accepted by a human being, it must look familiar. That's why the Japanese, ever since the 80s and the 90s, despite all the constraints and the limits of the technology, insisted on developing robots that looked as close to man as possible, or to look as an animal at least. You've seen the Paro in the video clip, designed by a robotic engineer, the seal that can be used by therapists to treat early stages of autism in children. And it's even better than the pet, the real pet, because you know that autism implies not being able to interact with other human beings. So therapists do use pets to treat these children, but a pet may make an unexpected movement, which is something that a robot pet doesn't do. So using technology, using the robotic pet, you can record the progress made by the child, by the patient, because the machine can be used to assess in an unbiased way what the patient is doing. So what you've seen in the video clip is certainly futuristic, but thanks to the fact that the technology is there, the technology is mature already. So, for instance, a mechanical arm that acts and behaves exactly like a human arm. And this is what makes us think of what is going to happen in the next decades, where we will have machines that look closer to man or other animal species. And these will be robots or machines that can not only perform the tasks that we want the robot to perform, but they will also look like animals or man. Among the science fiction films that I've seen, what impressed me most was not so much robot, that I found it rather, dull, but the movie that I was most impressed by was entitled Ex Machina. So there's a human being who's facing a droid or a robot, and the only way to know whether there was a human being or robot was by cutting the arm of the robot to see whether there was blood or a microchip underneath. So when I was a student,
Ora siamo nel 2022 e spesso la finzione, l'altro film che
there was a science fiction film that was very popular, the 2001 Odyssey by Kubrick. And
in uno scenario post-catastrofico, no?
and then there was the cartoon Wall-E, a robot in that
Non a caso i nostri colleghi
got moved by watching a scene of love on TV. So neuroscientists talk about sensitive machines. In other words, machines that are able to feel, to have feelings. You may think this is impossible, but in fact it is possible. If I got an assistance robot, for instance, a robot meant to assist the elderly people or children, because these are the two groups of the population where robots are already a fact. Then there are other groups in the population that may appear not to need these robots, even though the need may arise when technology is seen as something advantageous. Bertil said it. The exoskeleton was developed to enable a paralyzed person to walk, to have a sensory motor activity similar to a normal person. In Italy, there is a product called Mate, an exoskeleton developed by Comau that cost 5,000 euros. So we're not down to the 1,000 euro of a tablet or a smartphone or a computer, but you see the price of this technology is decreasing progressively. I'm saying all this because this technology is constantly evolving, and it will inevitably have to be accepted by human beings. I talked about sentient machines. If you have a robot that assists an elderly person, you may think that, considering that a robot is a machine, the elderly person may kick it or may abuse it or may try and cheat it. But as robots become increasingly intelligent, the robot can remember that there is the user A who is rough, and the other human being who is kind. So, and at that point, the robot can adjust to the human being the robot is facing. So we're not at the extremes of the film I mentioned, Ex Machina, where you have to cut to see whether you are facing a robot or a human being. But I believe that the conditions are there so that the intelligent machine, the intelligent robot, can give the opportunity to human beings to vent out their creativity. And I'm absolutely convinced of this. So let's hear whether there are questions from the audience or from the chat.
I can see one person who raised his hand. They should be waiting for the microphone for interpreters to translate. In the video clip you showed, one could see a man with a mechanical arm lacing his shoes. Just a few seconds of a sequence, but from what you can see in the video, it was as if he was controlling the mechanical arm with his own neurons, his own brain. So did we manage to create a connection between the machine and neurons? Shall I answer? Yes. Yes, that's a bionic man. Hand. The hand you saw. Well, actually, this is a hand manufactured by Osuk, marketed by Osuk. The technology is owned by Bionics. Anyway, Osur is marketing it. The prosthesis costs 16,000 euros. It is fully integrated with the neurons of the person. But this is a biomedical robot. This is not the exoskeleton you wear. There was an amputation, and that was a prosthetic hand. We have been collaborating with physicians over the years, and patients who do accept a prosthesis do so also for aesthetical reasons, and this is important because this is meaningful to them. But there is also a functional aspect that one should consider. The person who managed to lace up his shoes managed to do so after being trained. So our task is to make prosthesis more intuitive, easier to use. I mentioned the smartphone. If I buy a brand new smartphone, I turn it on. Well, I'm 60, so I'm not very good at this. But anyway, young people just turn on their smartphone, brand new smartphone, and immediately know how to make it work. And this is the so-called plug-and-play approach. If you go back to the prosthesis, the person who has an arm that has been amputated must be able to manage the prosthetic hand. Of course, there is a training and a learning stage, but our task is to make this technology more and more customizable, more and more intuitive, easy to use, so that can be very simple. But for instance, once we have a driving license, you won't be reading the instruction manual of the car. You just sit down on the seat and turn it up. I mean, this is the plug-and-play approach. I turn it on and I start it and I leave. This hasn't happened yet in robotics, but what you saw is a high-range commercial product. The bionic hand is still a high-end product, but it changed the person's quality of living. Why so? Because besides aesthetics, he now has a hand that he can use. Thank you. Are there other questions? There is a person there and also there. Please wait for the microphone. First of all, congratulations for your presentations, what you said. In my profession, I had to follow automated plans, but oftentimes we had to stop because we haven't got still skilled workers to make the factory work with robots. And I believe that this is still a huge problem, because it is true that we have super technicians, but in industrial world, if there is no super technician, the plant should still be capable of working. And then thinking of education, because you have to look for members of your staff. We always had great difficulties in finding skilled workers, or even system integrators who are well trained. It is very difficult to find skilled personnel, because schools, there might be exceptions, but in most cases, schools are using obsolete technologies to train their students. And I'm wondering whether teachers know what to teach, because if you are a teacher in these fields, you should take a training class on a yearly basis, because advances keep coming and technology is very fast. I don't know whether Bertil has something to say. You are more an industrial robotic expert. Did you have this difficulty in finding skilled workers in your field?
So I think there's there's a few aspects to this. One is that I think that from time to time there are companies that just have too high ambition level when it comes to automate a factory, and they can't make it happen. This is nothing new. I saw that maybe 30 years ago at General Motors. They were implementing a new factory, and it was was highly technological, and they were not able to ever get the plant started. They had to really take out much of the technology to be able to do something. And the reaction to that was that the next plant they built, which was the Saturn plant, they had no technology. They didn't have one single robot. It was all done by manual workers. And I think recently we have seen Tesla have some similar problems. I'm not really knowledgeable about that because I haven't been involved in that particular one. But I think they had to back off quite a bit in order to get the plant up and running. So, you know, over-ambition is something to keep track of. When it comes to, you know, shortage of labor, I'm not sure that this is really what you are looking at, but for many jobs there is a shortage of labor. Take, for example, arc welding. It's very difficult globally to find skilled arc welders. And the skilled ones that you have don't want to weld the same part 25 times a day, every day. So that's where I think, say, the new type of robots are going to come in, where you don't really start from scratch. You keep much of the equipment that was used for the manual welding, but you put in a robot to do the task of sort of moving the welding gun. And not only does that take away boring tasks from the skilled welder, who can sort of instead focus on programming robots for new parts, but it also improves the quality because to weld, you have to have a certain angle, and you have to have move at a certain speed and so on. And it's not so easy for a human to control that. For a robot, it's very easy to control that. So once the skilled welder has set everything up, you're going to get the same quality weld every time. And it's going to be much better than the manual one. But I think what you were really going after is that it's hard to find the people that can implement automation. That's where you guys come in. There is certainly a need for that, and there's going to be. I mean, if I am right in saying that we have only begun when it comes to robotics, almost everything is ahead of us. We're going to need tons of people who are capable of we can say, installing new automation cells. From the industry, we will see robots that are easier to work with, but definitely from the education side, there is much to be done. So you're working on the right things.
Concordo assolutamente con la domanda e il ruolo dei...
I fully agree with your question, and the role of system integrators, so-called system integrators, is key. And I must say that in Italy, we are well positioned because there are many companies, well, industrial leaders are well known because technology, at least for European robots, is ABB, KUKA, and Comau. Then we also have Universal Robot, for instance, or Franca. But anyway, all in all, there are objects that work well, that can also be easily interfaced, and the role of the system integrator is the one that will allow for technological leap to be achieved. This means that going back to what we said before, besides becoming a robotic expert, to use this technology to take a step forward, we need experts in the field of system integration. And this is the reason why in my research group, of course, we do not deal with system integration, but we use different robots. So we made them work in different conditions, from the factory to the inspection and maintenance of a gas pipeline, or as you saw in my video clip, the inspection of bridges, of viaducts. Suffice to think of the Morandi Bridge, the tragedy in Genoa, and the bridge collapsed also because of maintenance and inspection that could have been done with drones or robots instead of human beings, who failed in doing their job. And also these kinds of human inspections are very expensive. So in my research group, I have skills that range from prototyping, 3D printing, mechanics, and Bertil highlighted this very well. The expert of robotics is an expert of technology, but not just the mechanics or sensors. And we need to develop these kinds of skills. You rightly said that there are super technicians. Yes, truly enough. But as a professor of university, the robotics I taught 33 years ago is completely different from robotics that I'm teaching now. And I'm pretty certain that the osmosis amongst the various disciplines is taking place also in high schools, because in order to understand how to use a robot, both in a factory and in another field, we need to consider all these aspects.
Ringrazio. Abbiamo un'ultima domanda.
One last question that came from the web. Today, what are the safety regulations that one should comply with when we talk about robots? Is there any European rule about robot safety, given that we spoke about collaborative robots that are safe? Can we say something? Can we answer this question? Bertil, maybe the floor is yours.
Yeah, there are safety regulations, and it's a fairly complex network, actually, of regulations. They tend to be a little, they are the work of committees, so they tend to be a little bit behind the industry. So some things that are happening in the industry have not really been addressed in the standards. So I think that's, when it comes to collaborative robots, the most difficult part of the robot installation is actually to ensure that it's safe. You have to verify that it's safe, and someone has to sign that everything, all the rules have been followed and so on. But at the end, it's really the manufacturer that's responsible for the safety of the equipment in the factory. And today it's very difficult for them to actually check if everything has been set up right. There's no good way of doing it. So now I'm coming back to my favorite topic again, augmented reality. With augmented reality, you can see the safety zones, because with a robot like that, you can set up many zones. You can set up a zone which is a geometric shape that the robot is either not allowed to enter into or not allowed to get out of. You can set up as many as you want to, and you can regulate the behavior. So inside a certain zone, the robot can only move at a certain speed, and there are other things that you can set up, fairly complicated. Using a product like RoboStudio, you can work with the setup because you can see things. You can see the robot path, and you can see the safety zones and so on. You can enhance it by using virtual reality, so you can step into it. But once you get out to the shop floor, which is really where the certification needs to happen, it's hard. But with augmented reality, I think it's going to be a lot easier to do that. So that's sort of the other aspect of say, metaverse manufacturing, that invisible things can all of a sudden become visible.
Quindi la realtà virtuale ci può aiutare.
Virtual reality, therefore, can also help us in granting the safety. Virtual reality, the metaverse, could also help us in implementing safety in the physical world.
I normally don't listen to you, I listen to someone else in the headsets. But I think you asked, have we actually tried that?
Yeah.
And yes, we have, but we're not yet at the level where it's productized. So we're doing this in the labs. It will become product in a not too distant future, I hope, and it's going to be very, very helpful. It's almost going to be a necessity for this democratization of robotics, that can be done in a reasonable manner.
Molto bene. E io credo che...
Fine, thank you very much. The time has come to close our session. Thank you very much to our speakers. Thank you to our speakers. It was really interesting to travel into the future and present of robotics, and let's see what the future will be like. Thank you very much, and see you soon. Bye.
Buona serata.